Now that we learned about strings, integers, and floats, let me quickly dive into a couple of other key value types which we'll see throughout this course. For example, there is the bool or boolean value type. And this is a value type that can only hold two possible values, and that would be yes, no, or to be precise, the concrete values that can be stored are true, false. But we use Boolean values in any cases, in any operations where we need a yes or no answer, since we only have these two possible values, true and false. And that will especially become important later once we start working with control structures, a feature which we will explore at a later point of time in this course. Right now, I already want to dive into runes and bytes. And these are two kind of related or similar value types that can be a bit confusing, but actually shouldn't be. Bytes are the smallest possible storage unit we have in computing, and we can store single bytes in variables as well, and that means in the end that we can store single characters, single ASCII characters. So no special characters like the euro sign or emojis, but simple characters like A or 9, not as a number, but as text, the character 9. And runes are almost the same, but they can store more characters. So there we're not limited to basic characters, but we can also store emojis or anything like that. And this can be confusing. You might wonder why we even have a byte if we have the more powerful rune type as well, but as it turns out, there are operations where you only work with bytes in the end, and reserving extra memory therefore would be a waste. And in general, you will see examples for the usage of bytes and also sometimes runes as we progress in the course. Nonetheless, I quickly want to dive into these types right now and show you how they work and behave. And for this, still in this first app main function, which now became rather big, I'll add a new variable and I'll name this variable first rune and make it of type rune by adding the rune type after the name. And then we can create such a rune value by using single quotes. And this is now really important. It has to be single quotes. Double quotes are reserved for strings, and therefore for runes we should use single quotes. And then, for example, store A in here, or also special values like the euro sign, for example, or emojis. And then we can still print this and print the first rune and see what that gives us. If I now again run this firstapp.go file here in the terminal, what I'll get here is this number. And that's important. A rune in the end, under the hood, is just an integer. This special character is encoded as an integer. So this integer, 8364, is the unique identifier of this specific symbol, so to say. But in our code, we can work with this symbol, which is more human readable than if I would have stored such a number anywhere. Internally, it is represented as that number, though. That's why we see that number if I output it here. Now, if we want to output it as text, we need to convert it to a string by using the string command, which we wrap around first rune. Just as we used the float64 command around lucky number to convert this integer to a float, we can now use the string command around this rune to convert this rune, which, as I just explained, is internally represented as a number, back to a human readable string. With that, if we would now run this again, we also get the euro sign shown here. And again, I'm totally aware that this can be confusing. It is a type which you will sometimes encounter though, and it is a type which we'll see later in the course again, and therefore I wanted to introduce it here already. Now we also have that byte type, and therefore I'll add the first byte variable and make it of type byte. And there we can also store a value by using those single quotes again. If I now copy this line here and I output my first byte, that should all work. So we can also use the single quotes to create a byte. And if I now run this file, we see 97 here. Just as with a rune, a byte in the end is just an integer number internally, and 97 is the unique identifier of the A character here. Still, for us in our code, we have the human readable version with the A text. Internally, it's represented as this number. Now, the difference to a rune can be seen if we try to store the euro symbol here. Then you see I get an error, even here in the IDE already, in the editor, that this can't be used because it in the end overflows the available range. It's too big to be represented as a byte. That's why we need a rune for more complex special characters like that. Regular text or even numbers as text can be stored in the byte as well though. You typically do encounter this byte type once you start working with files and you, for example, read the content of a file into your memory, and that's therefore another type which you will see as you progress throughout the course. You don't work with runes and bytes that often. You especially don't create your own rune or byte variables that often. Nonetheless, I wanted to introduce them here already. By now, we learned a lot about variables and values and types, and we had a look at all these core types that we should know about right now. Now, before we progress further, I want to come back to the first type we ever had a look at, this string type here, and to string values in general. We explored some math operations, which we can perform on integers or floats, but we can also perform various operations on strings. For example, we can concatenate strings. For this, I'll go down there again to the end of this first main function here, and I want to create another variable which I'll name first name, and I'll use the := operator to create and initialize this variable in one step and let Go infer the type for me. And here I'll use Max since this is my first name, and then I'll add a last name and store Schwarzmuller, which is my last name, in here. By the way, in strings, you can use special characters just fine. So there you don't need to watch out to define this as a rune or anything like that. Strings do support special characters. And now let's say I want to combine first name and last name into a full name, which I could create like this, or I just want to output it as a full name. So I want to call print line and output the result of first name and last name combined. No matter if I store that in a separate new variable first, or if I combine it just in time here when I want to output it. It is something which we can do easily. Combining strings, concatenating strings is a common operation. And you do it by using your two strings and by then concatenating them with the plus operator. So this plus operator cannot just be used with numbers, but also with text to combine those strings. Now, if I would execute this file here, if we would run this first app.go file, then you would see that this works, but there is no white space between these two strings because neither of these two strings does contain a blank at the end of the first or the beginning of the second string, and Go thankfully doesn't magically add extra characters between the combined strings. And a blank Whitespace is a separate character. So if we want that, we simply have to add it as an extra string in the middle, and that's also something you can do. You can not just combine two strings, you can also combine three strings. Just as you could add or multiply multiple numbers in one operation, you can do that as well. So you have no limit to two values only there, and the same is true for strings. If I now run this again, now I get Max Schwarzmuller with a blank between the two names. Now it gets a bit more interesting if you start combining a string with a number. For this, I'll not combine first name and last name, but I'll create a new string value here. So I'll not store it in a variable first, I'll just create it here when I need it, since I only use it in one place anyways. And I'll store 9 in there. Now this is a number, but from the type perspective, it's a string. It's between double quotes. So it's not an integer, it's a string. Just to us humans, it's the number 9. Now let's say we want to add 1 here. If I add +1, if I type +1, I get an error, and the error is that now I'm trying to perform an operation that involves an integer and a string. And operations with such mixed types are simply not supported. It's kind of comparable to what we had before with the float, where we also had to convert the integer to a float first before we could derive a float as a result. Now here we have kind of a comparable problem when we try to add a number, an integer, to a string. And that would be the same if this would be a float, of course. You can create a float by just adding a dot here in the number, and then this would still not work. Here, to fix this issue, we would have to convert this string to a number first. Now there is an int command which we could try to wrap around this string, but this actually won't work. The reason for that is that we as a human know that 9 as a string could be converted to the number 9, but what if that would be max? How would you convert this to a number? Now Go doesn't look into your string and check whether it is a human readable number or not, and therefore it always assumes that this conversion might fail, and that's why this kind of conversion is not allowed like this. Instead, there is a separate package that can help us with conversions like that, which will help us parse strings and convert them to numbers, but we'll dive into this package a little bit later. For the moment, I just want to highlight this problem that mixed types can't be combined in operations, but that you instead have to decide for one type and then combine those values with supported operators, like we do it here with the string concatenation or in earlier examples with default math operations. Here I'll comment this out since this would cause our program to crash.